Hello, my name is Haris Muklis bin Wahiri. So I am from Group 1. We are going to present our project for statics. It is all tank storage. So this is our group, me, Haris Muklis, EH24037. And so for today, I will present about our project overview. So for our title is Statics in Oil and Gas, which is Oil Storage Tank Foundation. So the project is to explore the critical role of statics principle in designing and constructing foundation for oil tank storage within the oil and gas industry. And for the foundation design of these tanks is crucial to prevent structural failures, environmental hazard, and economic losses. Applying statics principle involve analyzing forces, moments, and load distribution to ensure the tanks remain stable and secure under various conditions. So the last one is our project objective. Is to understand statics by grasping the fundamental principle of statics, including the equilibrium forces and moments, which is essential for designing stable structure. The next one is the background. So for general overview, the design and construction of foundation for oil storage tank is the oil and gas industry are crucial application of statics principles within mechanical engineering. This foundation must be able and stable and safe to support the massive structures which that store large quantity of crude oil and refining products. So our applying in this concept is by applying the fundamental concept of statics, engineers can design foundations that prevent structural failures, reduce environmental risks, and minimize economic losses. Understanding this principle is essential for practical implementation in the real world. And so the first one, we are going to statics. So for the statics, we use two formulas, which is equilibrium of forces and equilibrium of moments. So the first one is equilibrium of forces, which sum of fx is equals to 0, sum of fy is equals to 0, and sum of fz is equals to 0 also. And for the applying is to ensuring that all vertical and horizontal forces, such as the weight of the tanks, wind forces, and seismic forces balance out is crucial for stability of the oil storage tank. And the next one is equilibrium of moments, which is sum of moment x, sum of moment y, and sum of moment z is equals to 0. It is, for instance, in an oil storage tank foundation. The moments is generated by external forces, such as soil pressure, uplift forces, and uneven settlement must be balanced to prevent tilting or rotation of the tanks. And the last one is materials. So the first materials, we are using steel for their structure. So steel are using due to its strength, durability, and affordability. This can be used for both above ground or underground storage. The steel tanks must adhere to stringent manufacturing and construction standards to ensure their durability and safety. So the next one is fiberglass. So for the fiberglass, tanks are known for their sturdiness and durability. The fiberglass provide the height resistance to the rust, leakage, and sediment accumulation. It also provide the height resistance to the rust, leakage. This made the oil tank storage can be long lasting for 20 to 40 years with a proper maintenance. So the last one is concrete, and the concrete will be combined with the steel. So the oil storage tank is typically made of reinforced concrete to provide stability and support. Usually, they use a concrete ring wall to support the tank shell. The steel bars or mesh is added to provide an additional strength and flexibility. especially important for supporting the large oil tanks. So the next one I will pass to Fakushi.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fakushi Syakiran Bilamli. My metric number is TH24032. So I would like to continue the presentation. My part is about the application. So the first point is important of oil storage tank foundation. Oil storage tank foundation are crucial for the safe and stable storage of crude oil, refined product, and petroleum derivative. This foundation must support large tanks that can hold thousands of tons of liquid with the potential for significant load shift over the time. Ensuring that these tanks are securely anchored to the ground is vital to preventing catastrophic failures such as tilting or sinking, which could lead to hazardous spill or structural damage. Proper foundation design addresses this challenge by providing the necessary stability, durability, and ease of maintenance over the tank's operational lifespan. Second is static principle in design. Uh, Static principle in design, the application of static principle in tank foundation design is essential to ensure that force and moment acting on the structure are in equilibrium. This involves careful analysis of vertical loads, such as the weight of the tank and its contents, as well as lateral force caused by external factors like wind, seismic activity, or uneven settlement. Dynamic loads arising from tank filling and emptying also need to be accounted for. Stress analysis, particularly focusing on pop stress in the tank walls, stress concentration around the base plate, and soil pressure distribution is critical to avoid foundation failure and maintain the integrity of the storage tank. Okay, next is soil mechanic foundation design. Soil mechanics plays a key role in foundation design as the bearing capacity of the soil beneath the tank must be sufficient to prevent settlement or failure. Foundation types are selected based on soil condition. Rainwall foundation are used for effective load distribution on stable soil, while pipe foundation are deployed in weaker soil to reach more stable layers. In some cases, ground improvement techniques like compacting, grouting, or the use of geotextile reinforcement may be necessary to enhance soil strength and ensure that the foundation remains secure over time. Next is case study and application. Case study of oil storage tank foundation illustrate the importance of applying static principle to real-world design. Floating roof tanks, for example, must manage the movement of the roof to change in the liquid level, requiring careful design to maintain stability while accommodating this movement. Fixed roof tank, on the other hand, must be designed to withstand varying pressure loads, both from the weight of the stored product and from environmental force. Seismic design also integrates dynamic consideration with static analysis to ensure that the tank foundation can survive earthquake and other ground movement. Next is tool and technology. Modern tools and technology are indispensable in the design and monitoring of oil storage tank foundation. Finite element analysis, or FEA, is a key technique used to simulate and analyze the stress and strain distribution within the foundation and tank structure, allowing for more accurate design. Surveying instruments are used to ensure precise placement of the tank and foundation, facilitating even load distribution. Additionally, sensors are increasingly used to monitor settlement and pressure change over time, providing real-time data that can be used to assess foundation performance and prevent potential failure. And the last point for the application is challenge and future direction of oil storage tank foundation. Oil storage tank foundation face several challenges that will continue to evolve with changing environmental, regulatory, and technological conditions. Environmental factors such as corrosion, flooding, or extreme weather event can compromise the integrity of both the foundation and the tank. adhering to increasingly stringent regulation and standards such as those set by ASME, API, and ISO is essential to ensure safety and compliance. Furthermore, the future direction of foundation design may involve greater use of sustainable materials and construction methods, as well as designs that are more resilient to climate change and environmental hazard, aiming to reduce the environment impact of oil storage operation. That's all from me. Thank you.
My name is Kishan Ranalake S. Ramachandran. Number metric GH24039. Today I'm going to present about the oil storage range, oil storage tank, and my part is emphasis on ethics and society. Okay. My first point is environmental responsibility. Okay, oil spills can cause catastrophic damage to ecosystem and water sources. Ethical responsibility mandates regular inspection, proper maintenance, and advanced leak detection systems. And the waste management also must disposable and treatment of oil residues and waste prevent environmental contamination. And companies are ethical responsible for minimizing greenhouse gas emission and adopting energy efficient technology. And number two is human safety and health. The workplace must ensuring compliance with occupational safety regulation OSHA standard is essential to protect workers from hazardous conditions and must ready emergency response plans. Ethical operation require robust emergency preparedness for incidents such as leaks, fire, or explanations. And the number third is regulatory compliance and transparency. Adherence to regulation, compliance with environmental and industry standards is not just legal but also an ethical responsibility. Companies must honestly report incident maintenance records and environmental impacts to authorized and stakeholders. And the number four point is community and societal impact. Companies should engage with local communities, addressing concerns and fostering trust. Ethical consideration involve assessing and mitigating health risks posed by emission leaks or contamination. Initiatives like local infrastructure development, healthcare programs, and education support demonstrate societal commitment. And the number five is ethical decision making and operation. Ethical companies prioritize safety and sustainability over cost-cutting measures that may lead to environmental or human harm. Decisions should be made with consideration for future generations, emphasizing sustainable resource management. Encouraging employees to report unethical practice without fear of retaliation ensure operational integrity. Last, industrial oil storage tank operation must align with ethical principles and societal responsibility, prioritizing environmental stewardship, worker safety, regulatory compliance, and community well-being not only prevents disaster but also build long-term trust and resilience. Thank you very much.
For the conclusion, in conclusion, applying static principle to oil storage tank foundation is crucial for safety, stability, and long-term performance. By ensuring balanced loads and addressing soil and environmental challenges, engineers can design durable and reliable foundations. This reduces maintenance costs and support the efficient operation of storage tanks. Overall, integrating static ensures safe, cost-effective, and sustainable solution for the oil and gas industry. That's all from us. Thank you.